velocity and acceleration in rectilinear motion, applications of derivatives it is there. So under velocity, and what is the velocity and what is the acceleration first of all? So velocity comes under any function it is here. First of all, before that we can discuss about what is the function, and then functional under rectilinear motion. What is the motion first of all? Motion of an objects, but it is in a path, that is a rectilinear path it is. The object which is moving in a rectangular path, that is called as a rectilinear motion. But what are the changes happened in the motion of an object? So with respect to the distance, with respect to the time, with respect to the velocity, etc., etc. So that will be carried out by velocity as well as acceleration. So there are such terms which we can use it as. First thing is distance, traveling by an object, time, and then displacement, and then velocity, and acceleration. So these are terminology which we can use more number of times under application of derivatives it is. So first thing is, if you take velocity, before that what is the distance? So the distance is distance and displacement both are category of represent the physical quantities it is abstractly, but one is a scalar quantity and other is a vector quantity. But what is the difference between the vector and scalar is, vector is both, in this case category, it will have a physical quantity which is having both magnitude and also direction it is. So direction, that is the reason it will be called as a vector. So that is the example for vector is a displacement it is. So it is a displacement it is. Displacement example it is. Because when you are discussing about the motion, so we need to know about the direction also. So that is the category comes under displacement it is. Next one is a scalar. What is a scalar it is? Scalar is no magnitude, and only magnitude it is, no direction. So no direction, only magnitude. So this is a scalar quantity, a physical quantity which is having both magnitude and direction is called as a vector. A physical quantity which does not follow it is follow no direction but only magnitude is called as a scalar quantity. So scalar quantity example in this case is distance it is, as well as some other examples also there it is, okay, but especially displacement and distance let's discussing here is. So what is the distance first of all it is? Okay, in simple way we can define it as, okay, a body, object which is moving from one point to another point. So one place to another place is called a distance. So that is from A to B it is like this it is. A to B it is. This is called as a distance which is covered. It might be straight line, it might be curve, it might be rectangular curve it is. So that is the reason it is come to be distance it is. Now that what is the time? So the time taken to reach an object from A to B is called, that is the time. So that means the object which is reaching, the time taken to reach the object from A to B is called as a time. So time, obviously we know that it is measured in terms of seconds, hours, minutes, etc. So and the distance is obviously kilometers, meters, etc. So now the time is already the time taken to reach the object from one place to another place is called as a time. So displacement, what is the displacement is? The shortest distance. It is important to know that the shortest distance between the two points A to B. But it is most important the direction it is. So in which direction it is going? Just like if you take the direction point of view, south, north, east, west it is. So that's why they are called as the directions it is. So here also, to define the displacement, the shortest path, the shortest distance between the 2 points in particular direction is called as a displacement of an object. Now come to the velocity. So as we know that if you are expressing this formula, so that can be written as velocity as well as the displacement, they are interconnected it is. So what is the displacement, what is the velocity? Displacement is already discussed, and what about the velocity? The rate of change of displacement with respect to the time is called as velocity. Let's take the velocity is equal to formula is equal to ds by dt. ds by dt it is. So that ds by dt is said to be velocity in this case. The short here is the velocity means it is ds. ds means it is displacement with respect to the time. With respect to the time is also called the speed, rate of change of displacement with respect to, this is called as a velocity. And then come back to this acceleration, and you must know that what are the units of velocity also. This can be taken as meter per second. So that means the object which is traveled from one point to another point in 5 you call it as a kilometer per hours, meter per second, like this it is. As we know that it is if you take 1 kilometer, let's say an object is moving 60 kilometer per hour, so 60 kilometer per hour kmph, then what does it mean? It is, that means it is in 1 hour it is traveling 60 kilometers. So the distance which they are covering is from within the 1 hour time is 60 kilometers it is. So in the same way here, velocity is nothing but meter per second, kilometer per hour, etc., which we can use it here. Velocity is considered. And last finally, acceleration. That acceleration is defines, finally this is going to be acceleration defines the rate of change of velocity. The rate of change of velocity means it is dv by dt is equal to acceleration. The rate of change of velocity, that is dv by dt. Therefore these units are going to be meter per second square. So meter per second square are the units of acceleration. So therefore velocity and as well as acceleration in a rectilinear motion. So that means is motion means it is the object which is moving in this direction.